Hello and welcome to this Python tutorial series. We are studying modules. Topic of today's video is to study statistics module. Overall goal of our tutorial series is to learn Python by implementation. Objective of today's session is to understand and compute mean, mode, median, variance and standard deviation. Let's start. To understand data, statistics play a very important role. It helps in collecting, organizing, analyzing and interpreting data. Data analysts use descriptive and inferential statistics. Descriptive statistics helps to summarize or describe the data. Inferential statistics helps to explain the data via relationship with other data elements. Today, we are computing descriptive statistics for the sample point available with us using measure of central tendency and measure of dispersion. In measure of central tendency, we use mean, mode, median, a single value which can collectively represent the data. Whereas in measure of dispersion, we see the distribution of data around the mean. We first import the third-party module statistics as S. Here what we are doing, we are giving a module alias S. What is the syntax? Import module name as alias name. We see the function inside module dirs. You can see by navigating it has mean, means the average of sample point, median, if the data points or sample points are arranged in ascending order or sorted order, it is the middle value. Median grouped, it is the average of the two middle value which will be given at the output. Median high, if your data points are even, then the higher value of the middle value will be selected. Median lower, left value of the two middle values will be selected if you have even sample points. Mode is highest frequency value. PSTDE and P variance is population standard deviation and population variance. STD and variance is for sample standard deviation and sample variance. What is the difference between sample and population? You don't perform computation on complete population. You perform computation on the sample and use those computation to analyze or describe the population. Let's compute mean. Now in the second import syntax, we are importing all the functions of library directly from statistics import star. You are not using any alias. You have one variable weight. Suppose this is a sample of the population of a given area wherein 60, 65, 68, 70 and 75 are weight of the person. If a single point can be used to describe this data, we can use a measure of central tendency as a mean of WT. You can say 67.5 means in that region a person can have a weight nearly about 67.5, a representative value for that population. If you don't pass any argument to mean, it will give a statistical error. Here mean function, inside mean function you don't pass any data, though it will give a statistics error. Now inside statistics you have module fraction as well as module decimal for representation of data points. In fraction you have a function fraction. We are giving it alias name as f. You can compute the mean of a tuple of values which are acting as fraction. So mean opening and closing parenthesis function. Then inside a list you have fraction 3, 7, 1, 21, 5, 3, 1.3. When you compute the mean, this fraction is the mean of the fraction which we are given as input. Decimal is also a function which is available in the module decimal, which is inside statistics, which will represent decimal values, and for this decimal value we will compute mean, and that mean will be represented as a decimal. Click on the cell, run the cell. If you are your data points have ratios, instead of using normal mean we use harmonic mean. Definition of harmonic mean is it is the reciprocal of average of reciprocals. Means you take the average of the data points which are in ratio and then you take a reciprocal of it, that will be your harmonic mean. In this case you have three ratios, 2.5, 3, 10, and those were price upon earning ratios. If you compute harmonic mean of those ratios, you get the output as 3.6. If you compute mean of those ratio, which will give a value of 5.166, which is a higher value as compared to representative value, which should be lower. So if your data is in terms of ranges or ratios, then in that case you can use harmonic mean or geometric mean. In statistics, directly harmonic mean function is available, geometric mean is not available. You have to compute geometric mean. If you want to compute geometric mean, you multiply the sample points and take the nth root of the sample points. Suppose you have two sample points, means you multiply s1 and s2 and take square root of s1 and s2 will be your geometric mean. One more point, mean are susceptible to outliers. If you have an extreme point in your data, for example in this case this 1000 is a noise, means weight of a person cannot be 1000, this is an outlier. If you compute mean of this data, mean of the representative of your sample is a value which is 199, which is incorrect representation of this sample data points. In that case you cannot use mean. In that case you can use harmonic mean, which will be nearly correct value, nearly correct representative sample for the sample points which are used. So we move from mean to median. Median is the middle value in your sample point, wherein half of the value of below the median are less and half of the value above the median are more. For example, if you have a data 60, 65, 68, 70, 75, 60, 1080, you will first sort the data and then you will select the middle value 1, 2, 3, 4, 5, 6, 7. Middle value will be 4, therefore median will be 68. Here see it is not affected by the outlier 1000. Now our data sample have even number of sample points. In that case, if you compute median, it will take two middle values 68 and 70, divide it by 2 and take the result with the truncation. The median of this value is average of two middle value will be taken. So it can be, you can use median grouped, or you can use median low, which will select 68, or you can use median high, which will give the upper value of the two middle values which are available when the sample points are even. If it is odd, single value is selected. If it is even, you can use grouped, low or high. Mode is the highest frequency value in your sample points. If you have sample points like this 65, 68, 70, 75, 60, 1080, highest frequency value is the value which is repeating maximum number of times. Click on this, wait, and mode. You will get an error that 7 values are unique value, no value is repeating. If you add repeated values to this data set, click on the cell, run the cell, and you compute the mode. Highest frequency value is 60. We have finished with measure of central tendency, where you add mean, average of value, median, middle value, mode, highest frequency value. Now we compute measure of dispersions. Generally, when you have a measure which is a real world entity, it is distributed normally. Means it is centered around the mean. It is a normal distribution or Gaussian distribution which will look like a bell-shaped curve. If you want to see the formula for normal distribution, it is y is equal to 1 upon rho into under root of 2 pi into e, raised to the power minus x minus mu square divided by 2 rho square, where data will be a bell-shaped curve in which 0 is the mean, means mean is around the centered. Mean is at the center and most of the data is centered around the mean. If you compute variance of the data in standard deviation and take the square root of variance, it will be standard deviation. In one standard deviation from the mean, you will get the 68% of data is occupied. In two standard deviation from the mean, 95% of data or sample point will be occupied. In 3 standard of deviation from the mean, all of the data will be occupied. We see the formula which are different for a population and sample. We see mean, summation of all the points divided by n. We see variance, it is the difference of the sample point from the mean for each sample point taken as a square, which is summed and divided by n minus 1, where n minus 1 is a correction, Basel's correction to remove biases in case of sample. If it is population, then the data point is subtracted from the mean, square is taken, this computation is done for all the data points, they are added and divided by n, that is variance. Standard deviation is square root of variance. Suppose we have sample points 60, 65, 68, 70 and 75. We take mean of this sample points, you get 67.6. If we compute variance of this, then we have to write variance WT, it will be 31.3. If you compute standard deviation of this weight, it is 5.594. What does this value indicate? From the mean 67.6, if you go left to 5.5 and right to 5.5, 68% of data will be, data points or sample points will be covered, because the distribution is a normal distribution and we are using single standard deviation. It's if this data point was not sample but they were population, then the population variance and population standard deviation function will be used. The PWD. Why we get the change in the value of variance? In case of population, you divide it by n, and in case of sample, you divide it by n minus 1. We have seen this in the formula. If it is a population, you divide it by n. If it is a sample, you divide it by n minus 1. So we have seen mean, median, mode, variance and standard deviation for a univariate variable. For more such technical contents, do hit the subscribe button.